Hello everyone, in this video tutorial, we will build an intuition around object detection. We will see what does object detection means, what are the applications of object detection, and what are the famous object detection algorithms. Object detection is a computer vision technique used to identify and locate objects within image or video. Basically, object detection draws the bounding boxes around the detected objects, which allows us to locate objects that are in the image or video frame. Object detection is often confused with image recognition. Let's clarify the distinction between them. Image recognition assigns label to an image. A picture of deer will receive the label deer. A picture of two deers will receive the label deer. While object detection, on the other hand, draws a bounding box around each of the object. It draws a bounding box around detected objects like car, bicycle, person, traffic light. The model predicts where each object is and what label should be applied. Object detection provides more information than image recognition. Object detection remains foundational task that underpins grunt work on making self-driving cars a reality. Real-time car detection models are the key to the success of autonomous vehicle system. These systems needs to identify, locate, track objects around them in order to move through the world safely and efficiently. Object detection models are capable of tracking multiple people at once in real time, from retail store to industrial factory floor. This kind of granular tracking could provide invaluable insight regarding security, workers' performance, and safety and retail for traffic and more. Object detection can be used in medical diagnosis using patient data and other information. It can help doctors and other medical providers to deliver more accurate diagnosis and treatment plans. Today, object detection is used in tumor detection, neurological diagnosis, health monitoring, remote patient monitoring as well. Nowadays, object detection approaches involves the use of deep convolution neural network. Initially, researchers were using convolution neural network based region proposal method like RCNN, fast RCNN, and faster RCNN. We will look in more detail into each of this approach in the coming lecture. The second is single shot multi-box detector SSD. SSD method takes single shot to detect multiple objects within the image, while region proposal networks take two shots, one for generating region proposals and one for detecting the object of each proposal. Thus, SSD is much faster than two-shot region proposal network-based approaches. The third is YOLO algorithm. YOLO algorithm revolutionized the object detection domain. It was released in 2015 by Joseph Redman. Till now, YOLO has achieved a lot of popularity because of its speed and applicability. In this course, we will be working on object detection, custom object detection, object segmentation, custom object segmentation, object tracking using deep sort, plus pose estimation. We will be building different applications using pose estimation model, plus we will be building our web applications using Flask as well. So let's get started. Hello everyone, in this video tutorial, I will present a review about YOLO V7 research paper. Let's understand what this paper is all about in this video introduction. In this tutorial, we will talk about abstract of the paper. How does YOLO V7 works? What approaches did they use in YOLO V7? Why did they use the particular approach? Model comparison section, we will compare YOLO V7 model performance with prior YOLO models, and we will see why YOLO V7 is so awesome. YOLO V7 trainable bag of freebies sets new state-of-the-art for real-time object detectors. We will learn what bag of freebies mean in the later part of the video. The paper states that YOLO V7 model can officially predict video inputs ranging from 5 fps to 160 fps, an average precision of 56.8% has been achieved using YOLO V7 model. YOLO V7 outperforms both transformer-based object detectors as well as the convolution-based object detectors as well. Some of the object detectors that YOLO V7 outperforms are YOLO R, YOLO X, Scale YOLO V4, and etc. So here I have presented a comparison between YOLO V7 and YOLO V4. YOLO V7 and YOLO V4 both are bag of freebies model. YOLO V7 has 75% fewer parameters than YOLO V4 and 36% lesser computational time. YOLO V7 has 1.5 times higher average precision than YOLO V4. YOLO algorithm uses convolutional neural network to predict the bounding boxes and class probabilities, considering the entire image in a single evaluation in one step and for one unit. YOLO predicts multiple bounding boxes, class probabilities for each box and all the bounding boxes across the classes, making it one-stage object detection model. Here is the YOLO architecture. Image frames are featured through backbone, which is then combined and mixed in the neck, and then they are passed along, and YOLO predicts the bounding boxes, the classes of the bounding boxes, and objects of the bounding boxes. Let's understand each of the modules separately. So the first thing we have in the architecture is input. The input image is nothing but the image input you provide. It can be a two-dimensional array with 3 channels, red, blue, green. It can also be a video input at each frame of some image input. In the YOLO architecture, after input, we have the backbone. So what is the backbone? Backbone is a deep neural network composed mainly of convolution layer. The main objective of the backbone is to extract the essential features. The selection of the backbone is the key step, as it will improve the performance of the object detection. Often pre-trained neural networks are used to train the backbone. Some of the commonly used pre-trained networks are VGG16, ImageNet, RetinaNet, ResNet 50. For YOLO V7, the paper uses the following pre-trained weights: VOVNet, CSP VOVNet, ELAN, and E-LAN. So after backbone in the YOLO architecture, we have the neck. Object detection model inserts additional layer between backbone and head, which are referred to as copy of detectors. The essential role of neck is to collect feature map from different stages. Usually, neck is composed of several bottom-up parts and several top-down parts. For enhancement, we use FPN, RFP, PAN. After neck in the YOLO architecture, we have the dense prediction part. Detection happens in the head, so the head is also called as dense prediction. To set the detector to decouple the object localization and classification task for each module. Once the detector has made prediction for classification and localization at the same time, this layer is present only in one stage. After detectors like YOLO, SSD, and RPN in self detectors, they are completely different. The last thing in the YOLO architecture is sparse prediction. Sparse prediction is for two-stage detectors, which include FRCNN and RFCN, but our YOLO is one-stage detector. Together they form a complete YOLO architecture. So here is the YOLO architecture. I have explained you each of the parts separately in detail, so I hope you have understood each of the parts. Let's dive deep into the topic and technical details I told you before. Bag of freebies model refers to increasing model accuracy by making improvement without actually increasing the training cost. The older version, YOLO v4, also uses the bag of freebies model. Batch normalization is an activation topology and EMA model is used as final inference model. During YOLO v7 research, it was figured out that the average precision was higher when the IOU threshold was increased. Like you can see over here, like when IOU threshold was 0.65, the average precision was 52.9%. And when the IOU threshold was increased to 0.70, the average precision increased to 53.0 and 53.1%. So increasing the IOU threshold increases the average precision. This was figured out during the YOLO v7 research. Intersection over union is a term used to describe the extent of overlap of two boxes. The greater the region of overlap, the greater the IOU. When we train our YOLO v7 model, our aim is to output a box that is perfectly around the object. So IOU stands for intersection over union, and it is equals to area of overlap divided by area of union. So the green bounding box over here, this green bounding box represents the ground truth bounding box, while this red bounding box over here represents the predicted bounding box. Predicted bounding box is the prediction from our YOLO v7 model. The aim of the YOLO v7 model is to keep improving its prediction until this red box and the green box, this green box, perfectly overlaps. This is when the IOU between two boxes equals to 1. So here the comparison of YOLO v7 model is presented with YOLO R and YOLO v4. Starting with YOLO v7 tiny, which you can see over here. Okay. So the YOLO v7 tiny model is the smallest in the family with over 6 million parameters with a validation average precision of 35.2%, which you can see over here. Okay, it beats the YOLO v4 tiny model, which you can see over here, and your average precision with YOLO v4 tiny is obtained as 24.9%. So it beats the YOLO v4 tiny model with similar number of parameters. Okay, so we can see over here YOLO v7 tiny model gives better average precision than YOLO v4 tiny model. The YOLO v7 normal model with 37 million parameters, which you can see over here, YOLO v7 normal model gives 51.2 average precision, which you can see over here. It beats the YOLO v4, it beats its variant. You can see over here YOLO v4 and YOLO R, YOLO v4 and YOLO R, which have more number of parameters. Like you can see over here, YOLO v7 normal model has 36.9 million parameters, while YOLO R and YOLO v4 has 52.9 million parameters. But with YOLO v7 normal model has better average precision than YOLO R and YOLO v4 respectively, which you can see over here. Okay. The larger models in the YOLO v7 family, which you can see over here, YOLO v7 D6, YOLO v7 E6, and YOLO v7 E6E. So we can see that all of these YOLO v7 larger models beat the YOLO R and YOLO v4 model, and YOLO v7 larger model gives an average precision of 56.8%, which beats the YOLO VR, which gives an average precision of 56.1%, and YOLO V7 E6 also beats the YOLO R model. YOLO V7 E6 gives an average precision of 55.9%, while YOLO R E6 gives an average precision of 55.7%. So in all cases, we can see here YOLO V7 outperforms the prior YOLO R and YOLO V4 model. So that's all from this video tutorial. See you all in the next video tutorial. Till then, bye bye.